So good evening. So today I'll be conducting your NPTEL this network analysis problem solving and doubt clearing session. So I will be focusing on week 11. Also we'll be considering two-port networks, which already we did last time also, but there are further aspects of it which we have to consider, as well as further sums we will solve. Okay, so I'll share my screen. So you're able to see my screen?
Yes, sir, it is possible.
So this is for week 11. So did you attend week 10 session?
Yes, sir, I was there.
Okay, so what are the 4 parameters which we have?
Z parameter, Y parameter,
Okay,
H parameter, and ABCD parameter.
so there is your Z parameters, there is your Y parameters, there's your H parameters, and then you have your last one, that is your ABCD parameters. Okay, so
Yes.
these are the parameters used to represent a two-port network. And the important consideration is this your two-port network, and there will be no internal source. So this is your V1, this is your I1, this is your V2, this is your I2. Okay.
Yes.
So there will be no internal source, we will consider it. And these are the various parameters which are used to represent a two-port network. So what do you mean that okay, we will consider symmetrical property, okay, symmetrical network. So when I tell the word symmetry, what comes to your mind?
Some parameters should be equal, like
Okay. Or just in general, in life, a particular object or some person or anything. Like, what do you mean by something is
equal half, equal half.
equal? So, in like it is sort of like evenly distributed, or like from
Yes,
the like if you see it from one side or another side, it will look the same. Okay. So, in your two-port network, like symmetry means the impedance. Like we have studied Z parameters. So there are various impedances are there, Z11, Z12, Z21, Z22, etc. So the impedance seen at one port, okay, should be equal to the impedance seen at the other port. If that happens, then we say that the network is symmetrical. So let me just show it to you. Suppose this is my two-port network. I have voltage V1 is over here, I1 is over here, and there is some V2, there is some load connected, there is some I2, etc. So this is our V1 is our input, I1 is the current which is flowing due to that input. So this is your V1 upon I1. Suppose your V1 upon I1 is some X. Okay. Now this same network, same two-port network, this is some other load to assume. This is your some V1, this is your some I1, this is your some V2, and this is your I2. Now, in case your V2 upon I2 is also equal to X. So your V1 upon I1 is X, your V2 upon I2 is X. So effectively, your V1 upon I1 is equal to your V2 upon I2. then you say your network is symmetrical. Because from any direction, from either from the network 1 or from the network 2, I apply some sort of supply or some sort of input I apply, then what the input sees in the network is same. Like uh, you're entering into some place, like if you are entering into a house, okay, you're entering into a house, you enter through the front door, and what you see is the same. Now, in case the house is symmetrical, it also has a back door also, and inside the house, all the rooms, everything are in the same fashion. So when you come from the other side, also from the when you look into from the back door and you see the house, it will also look the same. Then you say the house is symmetrical. So what you see as you enter is the same. It doesn't mean that inside everything is symmetrical from both directions. That doesn't always happen. But from when you enter, when you look into that house or into your network, it looks the same from the front side as well as from the back side. Then you say that your network is symmetrical. Yeah. So, mm, so what are the equations for H parameters? What are the how do we represent H parameters in terms of matrices?
V V11 is equals to
V okay V1 is equal to
H11
H11
one
H11 into
V2.
this is H11 into V2. Then it cannot be V2, right? So it is V1 is equal to H11. So one is for this, one is for something else, and then something else has to be current. So it is H11 I1. Okay, then you have H12. So what one is for your V1. So two is for what?
V2
V2. Okay. Next over here, what is the equation? What's the second equation?
I2
I2.
I2 is equal to H21 into what?
I1
Hmm? Yes,
plus
H.
H22 V2 V2
Okay. So these two equations you represent it as V1 I2 is equal to H11 H12 H21 into H22 I1 and V2. Okay. So these are my H parameters. Now we have to check what will be the condition for the network to be symmetrical. So how will we solve it?
We should find V1 by I1 equals to V2 by I2, right?
Mm-hmm. No, for like in the case for Z parameters, um, in the case for Z parameters, which are known as the open circuit parameters, the condition for symmetry is Z11 should be equal to Z22. And we get that when your Z11 is what? Your Z11 is V1 upon I1 at the condition that I2 is 0. That is, your I2 is 0. What does I2 equal to 0 mean?
Port 2 is open circuited.
Yeah, it is open circuit. Similarly, your Z22 is equal to V2 upon I2 at the condition that I1 is equal to 0. Okay. So now we will apply the same thing for your H parameters. So we will consider so this is your two-port network. You apply your plus minus V1. This is your I1. This is your plus minus V2. And your I2 is equal to 0. So how will we solve this? So we have the condition that my I2 is equal to 0. So we know that V1 is equal to H11 I1 plus H12 V2, right? And we have I2 is equal to H21 I1 plus H22 V2. We know for this case I2 is equal to 0. If I2 is equal to 0, what do I get? So I put I2 is 0, this is 0 is equal to H21 I1 plus H22 into V2. So my V2 is equal to minus H21 I1 upon H22, right?
Yes,
Any
sir.
doubt here? So now what I do is I put this in this equation. So I get V1 is equal to H11 I1 plus H12 into minus of H21 upon H22 into I1, sorry, into I1. So I get effectively V1 is equal to I1 into H11 minus H12 into H21 upon H22. So I get my V1 upon I1 is equal to H11 into H22 minus H12 into H21 upon H22. This is my equation A. Okay. Now we have found the first case V1 upon I1. Now we have to find V2 upon I2. So again, I have my two-port network. This is left open circuit. This is V1. Sorry. So my I1 is equal to 0. This is my plus minus V2 and this is my I2. Okay. So we know we have V1 is equal to H11 I1 plus H12 V2 and my I2 is equal to H21 I1 plus H22 V2. So I will apply the case that my I1 is equal to 0. Then what will I get?
H12 is equal to V1 by V2.
Sorry.
H12 we will get it. V1 by V2.
Okay, H12 is equal to V1 by V2. Then
And the I2 is so we can also get that H22 is equal to I2 by V2.
so what do we want?
We can substitute this H12
No, but what are
in
we
I2.
looking for? Like what?
Symmetry we will be looking.
So what is the condition I'm looking for? If I am looking for some particular condition, right? So for symmetry, as I told, symmetry is like you're looking into your network. So now I'm looking from which direction? From which port I'm looking into my network?
Now we are looking into first port from first port, port one.
No, we are looking in from port 2.
Okay.
Okay, I'm looking in from port 2. And from port 2, when I apply what I've applied, I have applied a voltage. And what is entering into, and then what is the current entering in? So that is what I'm looking into the network, right? So now,
V2 by A2.
yes, so I'm looking for V2 upon I2 is equal to 1, sorry,
H2 1 by H22.
H22. Okay, so now I will, and for symmetry, what I want my V1 upon I1 should be equal to V2 upon I2. So what is my V1 upon I1? H11 into H22. It is H11 into H22 minus H12 into H21 upon H22 is equal to 1 upon H22. So I'll effectively get H11 into H22 minus H12 into H21 is equal to 1. This is the condition for symmetry. Okay.
I mean, I have a question. Here we are talking about hybrid parameters, right? So
Mm-hmm.
Z parameter case we can open, Y parameter case we can short
Mm-hmm.
unnecessary ports. I mean other ports. But hybrid parameters also we are opening on the both sides, right?
Mm-hmm.
So why should we open it? I mean, as per hybrid parameters, maybe we may need to short one port at a time, right? Why should we open it? It's a
Mm-hmm.
mixed parameters, right?
Yeah.
V1 I1 combination.
Mm-hmm.
So in that case, why should we open them?
Okay. Actually, firstly, I have made a mistake over here. Over here, when I said, suppose this is, I've told that I am playing V1 and this is I1, this is V2 and I2. So this is my load. Okay, this is my load. I This is my load 1 and this is my load 2. So it is if you are looking for symmetry, then your load 1 should be equal to load 2. Okay. Otherwise, it is not the right way to do it. Okay. So when you're doing Z parameters, what you're doing, your load is infinite.
Hmm. Yes.
Okay. Your load is infinite. So load at both this port and at this port is infinite. And your input is V1. Your input still is V1. Okay. In next case, your input is V2. Your inputs can change. Okay. Your V1 should not be equal to V2. That is not mandatory. But the loads should be equal. Okay. So this one I missed. Your load 1 should be equal to load 2. That is the condition. So in Z parameters, your load is infinite. In Y parameters, how much is your load?
0.
Your load is 0. Okay. So one
Only.
question. Uh, if you have some, you have 2, 3 electrical appliances. Okay. You have 2, 3
Okay.
electrical appliances. And what do I say? You have a heater, you have a tube light, and you have a charger, assume. Okay. So in which case the load is more? If your power rating is more, mm, suppose I have speaker. Okay, I have a speaker. Power rating is 1 kilowatt. Okay, I have a heater. Power rating is 500 watt, and I have a tube light. Let us say power rating is probably 80 watt. Okay, in which case your load is more.
More.
Hmm.
Oh, speaker is consuming a lot, right?
Okay. Okay.
So load means the with respect to power consumption, speaker is taking more power, so load is more
Okay.
compared to heater and tube light. When tube light is acting alone, at that time we'll be having minimal load compared to speaker and heater.
Okay. Ah, that's a good thing to say. So then, for Z parameters, it is like what load? Load is how much then in that case?
Load is infinite, right? So it is open circuit, so almost in the order of, so it will be like a low voltage, right? Low wattage, because current consumption is very less.
Uh,
That is one thing, but the voltage it would be higher, right? Because even though we are having minimal current flowing through that, and voltage multiplied by the load impedance value will give us high voltage. So there it is a conversion process, right? Voltage and current. Voltage is more, current is less. When we
mhm.
have low impedance, current is more, voltage is less. So more or less power is same. It is based on the sink.
Mm, Actually, for open circuit parameters, I see this is the confusion. This your load can be in terms of wattage, it can be in terms of impedance, it can be in terms of
Hmm.
current. Now,
Right.
in this case, your speaker has lower impedance as compared to your heater and tube light. Why?
Let's consider that all are operating at the same voltage.
It is required because if you see in your house, you're going to get 230
Yes.
volt or 220 or
Ye-
240 volt. So your
Correct,
input is
correct, correct.
the same, voltage will be the same. Hmm.
Yeah. So if that is the case, the more current consumption device is speaker.
Yes. So because it is consuming more current, what should be the impedance?
Low impedance.
Impedance will be lower. Yeah. So these are like some MCQ questions come from this, at least when you have your placements, etc.
Yeah,
So that
I mean, we should be having that statement, right? All are operating on the same voltage. Otherwise, devices might be
uh,
operating at different voltages. Maybe
well,
some
now
conversion process happened.
see, conversion process is there. Like if you have your charger, if you have your mobile charger, it is having input 230 volt, but its output will be 12 volt or 5 volt or something. Okay.
Correct, correct.
Well, there's some conversion is happening. But what I'm saying is I'm looking into my input. My input is the same, right? My input voltage remains the same. My current is changing. Hmm. And so if you're looking into your input, it is also a two-port. Your charger, mobile charger also is a two-port network, right? It has an input 230 volt and some current is drawing, and your output is some 5 volt DC and some current is flowing out, right? So when you
Right.
effectively this two-port network, what is your input impedance you are seeing? So in the case of your mobile charger, which is consuming very less power, it will show high input impedance. But in case of your speaker, which is consuming a lot of power, it will show lower input impedance. Okay,
So
that's
these hybrid parameters are to make when the load is equal on the both sides. Let us say, in that scenario, it is applicable, right?
yeah,
Both
yeah,
the
yeah.
loads are same.
Yes, yes. Both the loads have to be same.
Hmm.
So it is very easy when you do, open circuit or short circuit. First, when you do that, like something is becoming zero. When something is becoming zero, it is easy to eliminate it. Okay, so that's why
Hmm.
we use that. Hmm?
What are the applications? Where are the applications of these H parameters? Jet parameters, we have seen that, right? In the power distribution, maybe we can see that jet parameters.
Power distribution usually, yeah, Z parameters also they use for representing your transformer everything.
No,
And
no, I'm not talking about transmission lines. In our PCBs or somewhere we have power planes, so maybe we can consider that our power planes, right?
okay, okay,
In
okay,
PCB.
okay.
So in that case, we will be seeing that the Jet 11, Jet 22. So how much load, how much impedance that it is seeing, so that we can optimize the impedance values, right? in order to reduce the noise, AC noise. Maybe in that direction we can see.
Probably I have not considered it like that actually.
Okay. That is also two port, right? Because we'll be having input and we'll be having output. Output is connected to the device. Input is from the power supply, let us say, whether it
Mm,
could be regulator or something.
okay, fine.
Then we should be able to see that how much impedance that is seen by the device, sync device. Load, let us say processor. Processor
Mm,
is consuming some power. So you want to understand how much impedance that it is seeing from the VRM point of view. When it is seeing from the
okay,
processor point of view, how much impedance it is seeing. We can
okay.
come to know that where are the maximum peaks that we are getting it. So that is a real case application which I can think of for the jet parameters, right?
Okay.
And the Y parameters may be inverse of these two, inverse of these jet parameters. But hybrid parameters, I don't know where we can use them.
Like
Uh,
hyperparameters are used for the BJT. The characterize the small signal model of BJT. Hybrid parameters are used.
but we cannot say that, right? Always load is same on the both sides, input side and output side. We don't know.
Uh,
Sometimes it may vary.
See, your parameters are considered at some particular operating point.
Correct.
Hmm. So at some or operating point, you have determined the H parameters of your network, and you will be using that. So now if you see, if you want to find your H parameters of your network, what do you do? You will, if you say, if you do, or this is your H parameters equations. I want to find H11, I want to find H12, H21, H22. What I will do? What I will do, simple way is I will make V2 0. If I do V2 0, then I can get H11, I can get. I can even get H21, I can get, right?
Hmm.
Now, if I want, then if I want to find H12, H22, what I do, I make I10. Okay, through that,
Right.
I can easily get it. Hmm. So that's one method to do. Actually, I don't
This is
exactly.
for okay.
Hmm.
Looks like to me the circuit analysis, right? Not the BJT component itself. It is the component which is inside any circuitry. So the
Hmm.
characteristics of the circuitry, maybe we can come to know by this.
Hmm.
Because
Uh,
sometimes we are doing zero.
yeah. Okay. Also, it is
Okay.
related to the small signal model. It's not the large actual model. It's like the small signal model. The thing for your PGT.
I don't know the difference between those two. I mean, I have come across with these two terms, but I
Oh, difference between small signal and large signal. Hello. And here. Hmm. Yes. Tell. I can't hear still. Are you speaking?
can you hear me now?
Yeah. Now I can hear. Now I can hear. Tell.
Okay. So I mean, what is the difference, basic difference between the small signal and large signal uh,
Okay.
modems?
So this is a very like a good doubt.
Maybe top level answer, right? Because I've been hearing a lot of times during the tutorials also, but I don't know.
Yeah. So. mm Large signal is like how it behaves in the overall perspective. Like if you see uh, your characteristics of your BJT, this is your IC, this is your VBE. Okay. So if my VB is so much,
Mhm.
my IC should be so much. So this is the entire characteristics of my BJT. Now, so assume I take some particular operating point. Okay.
Okay.
And in the neighborhood of that operating point, it will look sort of linear. Okay, it will look sort of linear
Oh,
because
piecewise
this
linear. Okay.
is my BB and this is my IC. So
Mm.
how my BJT will behave in that
Mhm.
neighborhood, that is the small signal operation.
Oh, okay. Okay.
Okay, so the small signal operation is limited. It is limited and confined to some small region. Okay, and
Mm.
like what usually happens, let me talk in terms of you can say for a BJT. In a BJT, what
Okay.
do you do first? You have a BJT. BJT is like an amplifier. You're using it as an amplifier. Okay, your BJT is there. You're using
Okay.
it. So if you want to use it in that way, what is the first step which you have to do? Like, what is the first thing you will consider and you will make your circuit? Akash, you would have known BJT at least, no? This second year.
Yes, sir. Yes, sir. I just studied BJT.
So what have you studied about BJT?
First, we will draw the small signal model of BJT,
Okay.
and then based on that, we'll analyze how it works on different conditions. What is H11? What is H12?
Okay.
Anything you're asking specifically?
Like, yeah, specifically I was looking for something known as your biasing. You are biasing your BJT, right? Why do we bias a BJT? Hmm? So this is my BJT. Assume this is my BJT. It has some, this. This is my RC. This is my R.
Okay.
Able to hear me now?
Well, looks like there is some network issue.
Achha, yeah, I got disconnected actually. So, mm, just hold on 1 minute. Let me just share my screen. Okay. So you guys are able to see the screen?
Yes.
Yes,
Yes, we
sir.
can see.
So, so you have your BJT circuit like this, RC, RE. This is some, this is your boost your base. Okay, your R1, your R2. This is your ECC, and this is your ground. Okay. So
Okay.
what do these resistors do actually? What is the goal of these resistors?
And they
Biasing.
amplify the signal switches.
Mm-hmm.
The R1, R2, capital R1, R2,
Yeah, what do they do?
those are biasing, right? For biasing of the BJT. So you have to set that operating point
Mm.
of BJT.
Okay, it means at the operating point of the BGT. So what do you mean by operating point of BGT? Operating point of BGT, what do you mean by that?
I mean, by knowing this operating point of BJT, we'll come to know the characteristics of the BJT such that while amplifying, we can come to know that what kind of amplification that it can do with that particular operating point, whether below that operating point or above the saturation point, we will come to know, right?
Okay.
So BJT will be having the characteristics. There will be some saturation cutoff regions, different regions will be having.
Correct.
So this operating point will tell us that where it is exactly falling, whether it is in the cutoff region or saturation or active region, how it is working.
Okay. So your operating point is where how much is your IC and how much is your VC, right?
Hmm.
That is your operating point.
Right. Yes.
So once you set that operating point, then you can consider your signal. Your signal will come. This will be your input signal. This is your coupling capacitor, and this is your output signal, right?
Yes.
So now your input signal will be of a small magnitude. It will be like say 1 millivolt something. Your output
Hmm.
signal,
Right.
depending on the gain, will be around let us say 80 millivolt or something like that. Okay. So you what what do you want? You want your input signal will be like suppose it's a sine. Sorry. This is your input signal. Okay. Your output signal you will want it to be something like this, right?
Hmm. Yes.
For this to
Yes.
happen, your BJT has to be in the active region, right? Then only you
Right.
can amplify. If it goes
Yes.
into cutoff or saturation, your voltage will not come. Or it will get clipped and clamped.
Right.
Yes. So basically, what you are doing, I'm actually don't not really remembering much, but let me say this is your IC and this is your VCE. This will be your load line. Okay, this will be something as your load line.
All right. Correct.
So in some particular region, um, like in between this region to this region, it will it can work as an amplifier. If it goes
Right.
outside the region, it will get clipped. Okay. So in that
Correct.
region,
Correct.
which it is operating linearly, that is where your small signal operation is happening.
So the
Mhm.
I mean the dotted lines where the present, that is like linear mode.
Yeah,
I
yeah,
mean
yeah.
where you have shown.
Yeah, it is like you're actually linearizing your non-linear behavior, and in small signal, you're analyzing how it will behave in that small neighborhood where it is linearized. Okay, so you have this large region. Okay, this large region. So I'm particularly interested and focused in this small region, and how it will behave in this small region is told by your small signal model.
Small variation. Okay.
The small variation in that. Hmm.
Okay. But if we try to see the same behavior between the regions, like cutoff region and active and saturation region,
And that is a
then that will be like
signal behavior.
okay.
Yeah. So that is very difficult to analyze, right? So basically, to simplify matters, you use a small signal model, and there are lots of constraints you must take into. So we considered when a network is symmetrical. Also, like that, there are similar conditions for a network to be reciprocal, etc. So, till now, anyone has any doubts? Anything to ask? Muta, Akash, Suresh.
No, sir. Nice.
Okay. So we'll start solving some sums. Calculator. So this is a week 11 previous year assignment. Here to solve. So how much marks are you guys getting in the assignments?
Good scores.
Good scores. Oh, that's nice.
So last 3 weeks it's fine. Before that, I got some low scores, but last 3 weeks I got.
Oh, that's
Just because of your lectures.
oh.
Yes, I should say that.
Uh-huh. Actually, this is
I
NPTEL.
mean, those 2, 3, 4 weeks are very hectic.
Which
Those are like
one?
linear equations, differential equations, right? The
Uh,
conventional differential equations. Oh my god. Those,
oh.
see, I just want to ask you one question. Can
Uh,
we directly jump into Laplace transforms while solving the problems instead of differential equations, right?
yeah, you
In order
can
to
do
solve
that.
them.
You can do that actually. It's not compulsory
Y-
that you must use differential equations.
Now we have some time, weekdays time, right, to solve those problems. But in the exam, we don't have that much time, right?
Uh,
So I'm just thinking that to convert entire things into S domain and then solve it
yeah,
quickly.
yeah, that is what I would do. Okay, because they know this is
So
MCQ, right? No one is going to check your steps. Even if they tell you you solve by differential equation and you solve by Laplace, No one will know. It's just MCQ. It is just ABCD, or it is just a numeric value.
I am thinking that this would be not MCQ or MSQ. It will be like blanks, fill in the blanks. That's what I'm expecting.
No, like what I know, I haven't given any exam of NPTEL, but to my knowledge, there'll be some standards. Like there are some amount of 2 mark questions, some amount of 1 mark questions. Some amount it has to be some amount has to be numeric answer type questions. Some amount has to be MCQ questions. So that it's like a sort of balanced question paper and all. It is
This is
not
my seventh
Actually,
paper for NPTEL.
okay. The previous one, what happened?
I mean, some are like MCQs only,
Hmm.
but one or two subjects there were like some fill in the blanks also.
Huh. There will be some fill in the blanks. Or fill in the blanks of what? Some numeric value or some word or something.
NAT, numerical answer type only.
Yes, 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 yes. That will come. That is a bit difficult.
but last time when my friend wrote the same exam, not this
Uh-huh.
one, but network analysis, he got completely numerical type only. There was no MCQ and stuff.
Okay, okay.
So this is what I'm expecting.
Yeah,
That's
yeah. It's like that only. It's,
because in the assignments also there's no options given, right? No options are
Yeah,
given.
yeah, yeah,
correct,
yeah.
correct.
There is no options.
Mm. Okay, I was thinking
It
someone.
is much tougher than GATE exam.
No, no, no. I don't think it's that way. Because the
Even
problem is quite simple
2024,
actually.
2024 GATE itself, out of 4 questions from the network, 3 were MCQs. One is only NAT.
Okay, no, no, but the level of question is difficult. No? This is quite simple because I was actually seeing the first year students' questions which they have to solve in IIT Kharagpur. That is so much more harder and difficult than these questions. So, like, even I have not solved such difficult questions on it. So, this we will have very difficult questions over here in IIT. These are quite simple actually, if you see. Mm, yeah.
Maybe we are not used to it.
Ah, even I was not used to it, so it's very difficult. So when we were taught with so much of time. So like in my BTech college, the teacher will come. She will also bring a set of. They'll have some teaching assistants, etc. And so we will be solving. If you have any doubt, we will ask the teaching assistant. Teaching assistant will help us, guide us what we are going wrong. They'll help us to learn how to use a calculator, how to do everything. So and then they'll give nice assignments. Till now, I have not been able to figure out from which book the teacher used to come up with those assignments. It'll be very difficult as compared to a normal book. But the amount of things they made us solve, it sort of, it keeps the concept in your head for a while, like that. Anyway, all these things also uh, you have to solve. Once you start solving, then you will be able to find some tricks and methods which work for you, which makes your so you'll be able to understand that this kind of sum, I have to use this method and all. And once you get into that flow of those methods, it becomes easier. But it takes time. So you'll have to practice. Anyway, your exam, when is your exam? On
21st.
21st, right?
on 20.
21st.
Okay. So now today's 9. So you will have, so I will have a session on 16th. That is for week 12. That is
Okay.
OPAMs and all. Then on 18th, I will have a overall summary session something. So that will be of 1 hour. Okay. So in that I will you can bring your doubts, like some doubts you have from this course. You can bring those doubts that time. That is not constrained to any week. Okay. Hmm. So I'll start solving this sum. So in this question, what parameters they are asking you?
It looks like jet parameters.
Z parameter.
Z parameters, right? Okay, so if it is Z parameters, um, so what should I do? Should I do open circuit and solve it or what?
Yeah, I2 make I2 is equal to 0, then we'll get
0.
jet.
Then we can, yeah.
That is one way. But easier way according to me is 1 minute. Actually, I remember this one. Let me see. So they're asking you this. Okay. Okay, so we will try using making I2 is equal to 0. So we are assuming open circuit. I assume open circuit and I put I2 is equal to 0. Then how will I solve?
Voltage across that resistor, right? Last resistor is V2.
Hmm.
And what is the current which is coming to that particular resistor? We can come to know in terms of I1. So we will get the relation between I1 and V2.
Okay. You, I say not to take open circuit. What I'll say is you consider just both I1, I2 is not 0. You apply KCL. You apply KCL at node 1. This is your node 1. So what you get I1 is equal to V1 upon R plus V1 minus V2 upon R, right? So your I1 is actually V1 upon 4 plus V1 minus V2 upon 4. That is equal to 2V1 minus V2 upon 4. Okay. Now, let me apply KCL at node 2. What will I get? Current which is coming in is I2 plus K into I1 is coming, that is 4 into I1. This is equal to what? Current which is flowing out. That is your V2
V2 by
upon R, that is V2 upon 4 plus V2
plus
minus V1
minus V1
upon
by R.
4. Okay, so now, mm,
Put I2 is equal to 0.
no, that is complicated. What I am seeing is, uh, mm, if you put I2 equal to 0, then you get in I1 in terms of V2 and V1. Still, you have to simplify it. No? You have to get I1 is, so see, if you put I2 is equal to 0, if you put I2 is equal to 0 over here, what you will get? You will get V1 is equal to E into I1 and V2 is equal to G into I1, right? Hmm?
Right. Yes.
But if I put I2 is equal to 0 over here, if I put I2 is equal to 0 over here, I will get what? I will get 4 into I1 is equal to V2 upon 4 plus V2 minus V1 upon 4. I'm still not getting it separately as V2 is equal to something I1 and V1 is equal to something into I1. That is not coming.
But we know from equation 1, right, where we can write V2 is equal to in terms of I1 V1.
Okay, so I'll use that. So I put I2 is equal to 0. So my 4I1 is equal to V2 upon 4 plus V2 minus V1 upon 4. So my 4I1 is equal to 2V2 minus V1 upon 4, right? Okay. Now over here, also I have I1 in the first equation is equal to V1 minus V2 upon 4. So what I do is I will take V2. So I will get 4I1 is equal to 2V1 minus V2. So my V2 is equal to 2V1 minus 4I1. So this I will substitute over here. So I will get 4I1 is equal to 2 into V2 is 2V1 minus 4I1 minus V1 upon 4. So I will get 4 into I1 is equal to 4V1 minus 8I1 minus V1 upon 4. So 16I1 is equal to 4V1 minus 8I1 minus V1. So that will be 24I1
20.
equal to 3V1. So V1 upon I1 is equal to 24 upon 3.
8.
Hmm? So this is equal
Yeah.
to my 3. Okay. Now I will substitute this over here. So what I'll get, my V2 is equal to 2 into 24 upon 3 I1 minus 4 I1. So my V2 is equal to, what is
12.
24 upon 3? 24 upon 3 is
8.
actually
16.
8.
12 I1. 12 I1. What?
so this 4 into 8 I1 minus 4 I1. 4 into 8 is 32. 32 minus 4.
2 into 8, right?
So this 28 I1.
No, no, no. 2 into 8, right? 24 by 3 is 8. 2 into 8, 16.
Okay, okay, okay. 2,
Not 4 into 8.
2 into 8. So 16 minus 4, so 12 I1. So 2 into 8. So this becomes equal to 12 I1. So V2 upon I1 is equal to G is equal to 12. 12 ohm. Okay, its unit is ohm. Mhm. So now, so I got V1 upon I1, V2 upon I1. Now what I have to do? I have to substitute I1 equal to 0 in the original equations. Okay, in my original equations. So if I substitute I1 is equal to 0, what will I get? So my I1 is equal to 2V1 minus V2 upon 4. So I1 is equal to 2V2. Let me just check again. It is actually 2V1 minus V2. 2V1 minus V2 upon 4. If I1 is equal to 0, what will I get? I will get 2V1 is equal to V2. Hmm? Any queries in this? Hmm? So I get 2V1 is equal to V2. Then in my other original equation, I2 plus 4 I1 is equal to V2 upon 4 plus V2 minus V1 upon 4. What is my other equation? I2 plus 4 I1 is equal to V2 minus V1 upon 4 plus V2 upon 4. So again, I will put I1 is equal to 0. So I will get I2 is equal to 2V2 minus V1 upon 4. Okay. So now, what is V2? V2 is given by 2V1. So I'll substitute that. So this is 2 into 2V1 minus V1 upon 3. So my I2 is equal to 4V1 minus V1 upon 3. That is equal to
V1 equal to I2.
okay. So that
Oh,
means
they
my
are divided by 4, right? I think 3 by 4. I think it is 2 into in the above step divided by 4. Instead of that, we have written 3.
अच्छा अच्छा my
I2
hmm. So my V1 upon I2, V1 is equal to
4 by 3. V1 by 2.
V1 is equal to 4 by 3 into I2. Okay. What will be my V2?
2 V1.
So it is 2V. So it is 8 upon 3 I2. So my V1 upon I2 is equal to 4 by 3 is equal to F. And my V2 upon I2 is equal to 8 upon 3 is equal to my H. Okay. Hmm. So now Now we will go to find the open circuit voltage gain and the short circuit gain. Okay, open circuit voltage gain, short circuit gain. Connected to port 2. Okay. So first, let us write this as. Let me add a new point, new page. We have V1 upon V2 is equal to E, F, G, H, I1 and I2, right? So that is V1, V2. What is my E? E, if I'm not wrong, is 8, I think. E is 8 and G is 12. 8, 12. And my F is 4 by 3 and my H is 8 by 3. I1, I2. They are telling to find the open circuit gain. What is my open circuit gain? AV is equal to V2 upon V1 when my I2
I2 is equal to
0.
0.
So if I put I2 is equal to 0, what will I get? I will get V1 is equal to 8 into I1. My V2 is equal to 12 into I1. So my voltage gain, which is equal to V2 upon V1, is equal to 12 by 8, which is how much?
3 by 2, 1.5.
1.5. Any queries in this? Shota? Oh. There, sorry. They're telling to find the short circuit gain. In the short circuit gain, what I have to consider? I have to consider I2 is there and you have V2 is equal to 0. Okay, my V2 is 0.
Gain 0, right?
Yeah, yeah. V2 is 0. Short circuit gain. So V2 is 0. If my V2 is 0, what I have? I know V2 is equal to 12 I1 plus 8 by 3 I2. So V2 is 0. So 0 is equal to 12 I1 plus 8 upon 3 I2. So 12 I1 is equal to minus 8 by 3 I2. So I2 upon I1 is equal to minus 12 into 3 by 8. That is how much?
4.5 minus.
That is minus 4.5. And your current gain AI is equal to minus I2 upon I1. That is how much?
4.5.
That is equal to 4.5. Okay. So now, voltage when extra 4 ohm resistance is connected to port 2. Achha. Again, 4 ohm resistance connected to port 1. So they are saying this is my 2-port network. Okay. You have some V1, you have some I1. And then you have some 4 ohm resistor connected over here. Okay. And you have some I2 over here and you have V2 over here. So what is the relationship between V2 and I2?
V2 by 4 is equal to minus I2.
Sorry?
V2 by 4 is equal to minus I2.
Okay. So you know your V2 is minus 4 into I2. Okay. Now they are asking, what are they asking in your question? Find the resistance seen from port 1. They are saying if I want, what is the effective resistance seen from here? Okay. So that effective resistance is what? It is actually V1 upon I1. So we know, where's my gain? V2 is equal to 12 I1 plus 8 by 3 I2. Right? Now I got to know that V2 is actually equal to minus 4I2 is equal to 12I1 plus 8 by 3 I2. Okay. Sorry. So what's happening? So I get minus 4I2 is equal to 12I1 plus 8 by 3 I2, right? So I will, what will I get? What is my I2? 8 by 3 I2 is equal to
minus 12I1.
So I get minus 4I2 minus 8 by 3 I2 is equal to 12I1. Then how will I simplify this? How will I simplify this?
We have I2 by I1 ratio also. Right?
Okay. So I get minus 12I2 minus 8I2 is equal to 12I1 upon 3. So that is minus 20I2 upon 3 is equal to 12I1. So I2 I can write it as minus 12 into 3 upon 20 I1. That is equal to minus 6 into 3 upon 10 I1. So my I2 is actually equal to minus 1.8 I1. Is this part clear?
Yes, sir. So, but we need V1 by I1, right?
Yeah. Okay. So now I know V1 is equal to 8 I1 plus 4 by 3 I2. So V1 is equal to 8 I1 plus 4 by 3 I2. So I did all this work just so that I can find I2 in terms of I1. Okay. So I get V1 is equal to 8 I1 plus 4 by 3 into minus 1 by 8 into I1. So what I will get as a final answer? Take out the calculator and do.
5.6 I1.
5.6. Wait a minute. Yes. It is 5.6 I1. So our input, which I see is V1 upon I1 is equal to 5.6 ohm.
Okay.
Okay. So this
Instead of doing all these things, right,
uh,
maybe we know that V1 by I1 already, right? That
uh,
Jedin.
okay.
So if we connect that parallel to that particular resistor, the equivalent would be like which is parallel to the Jedin, right? Jedin parallel to that 4.
No, no, it is not directly, right? But if you draw, if you see, if you draw it like this, this is your plus minus V1, okay? This is your 8 ohm, and this is your plus minus 4 by 3 I2. This is your I1. This is your plus minus 8 by 3 I1. And this is your, I think this is your 8 and what is it? And 12. This is your 12 and this is your 4 ohm, right? This is your I2. This is your plus minus V2. So your 4 ohm comes in series with your 12. and then these are certain complex relations. So it is just not simply adding in parallel or something.
I mean, if we try to calculate that V Thevenin's also, we'll be opening that, right? But we want to see that in from the V1 side.
Repeatedly.
I mean, we can do that V Thevenin's by I Norton so that we'll get that Z impedance, right?
Can you
Where we
apply?
want to see that impedance.
How?
So, for example, this theorem is added externally, right?
This one 4 ohm, yeah.
So we want to see that how much impedance that is seen by the same network.
Hmm.
So in
And
that case, what we need to do is we need to open that V1
okay.
and then we can chart V2 at one time, so that we'll get the current value from that.
No, V2 you can't short now because that is a 4 ohm resistor. How can you short it?
No, no. What I'm saying is, in order to find out the Thevenin's voltage, we will be opening that, right? We will be opening that,
No, if you want
and
to
in order
find
to find out the
no, if you want to find Thevenin voltage in this network, right? Where is your
yes,
voltage source?
on the left hand side we have.
But that only you're eliminating now when you're doing Thevenins. You're just removing that.
But I want to see that impedance from the port number 1, right?
Okay.
The effective impedance, what I'm seeing is from the port number 1, not from the port number 2.
Huh.
So
Okay.
if I come to know that VThevenin's value, right,
Huh.
that is one thing, and I can get the I Norton value also, so that I can get that input impedance, right, Zin
That
on
you
the
can
input side.
no my main the main problem which I am having with that approach is so
Okay.
this is your 8 ohm, right? This is left
Mhm.
open because you want to find VTH, right?
Right.
This is your plus minus 4 I2 by 3. Okay.
Okay.
This is your plus minus 8 upon 3 I1. This is your 12. This is your 4 ohm. Now, what is your I1? Your I1 is 0. Hmm? So, if I1 is 0, then
Right.
this is 0. If this is 0, your I2 will also be 0. Then this also will be equal to 0. No current is flowing. Then you get your VThevenin to be equal to 0. Which is not correct. Because the problem here is there is no independent voltage source available with you. And the only independent voltage source which was there, you have eliminated it. Then you cannot get any voltage over there, right?
Mm-hmm.
So that's why in this case you cannot apply Thevenin's voltage, Thevenin's theorem. So you're getting VTH to be 0. If VTH is 0, then even RTH and all will be 0. If RTH is 0, VTH is 0, then you just get V1. So that is not correct. So in this circuit, I think it is not possible to apply Thevenin's theorem here. Okay. Any other queries? Both of you are not having any doubts?
No, sir, no, sir. Clear, sir.
Hmm? Okay.
Clear, sir.
Mhm. Okay. So we can go to the next sum.
Yes, sir.
Mhm. let us put this over here. This is over here. Okay. So now, can you guys read this question?
Yes.
Yes, sir.
Okay, so how do you think you will solve it?
If I know the voltage V2,
Okay.
and if you know the current flowing through that RL, then we'll come to know that power delivered to RL. So I need V2 and I2.
V2 and I2. So, okay, so how will you do that?
So we have a relation between V1 and V2.
Okay. What's that relation?
V1 is equal to Z11 I1, sorry.
Okay, so you have V1 is equal to Z11 I1 plus Z12
Plus
I2.
Z12
Okay.
I2.
So over here, V1 is equal to 40 I1 plus 60 I2. Right? Okay, then
V1 is 40, right? It's given.
yeah,
V1 is not 40, Vs is 40, right?
Vs is 40 volt. Vs is 40 volt.
Oh, sorry.
Vs is 40 anyway.
Hmm.
Okay, now I need to get the V2, I need to get it.
Okay, but you have no V2 is equal to 70 I1 plus 110 I2. Hmm? Okay, so how I will tell you to solve this?
Can't we find V1 first?
Find V1. How will you find it?
Oh, we don't know I1 also.
So what I do is I apply KVL over here. So I apply KVL over here, what will I get? I will get Vs.
Vs minus
Hmm.
I1R,
Hmm.
yeah, 20 I1
Hmm.
minus
Plus
V1,
minus V1 is equal to 0.
0.
Okay, so I get my Vs is how much? 40.
Okay.
To 20 I1 plus V1 is what? 40 I1 plus 60 I2. Right?
Yes.
So 40 is equal to 60 I1 plus 60 I2. So I divide both sides by 20. So I get 2 is equal to 3 I1 plus 3 I2.
Minus sign will come. Okay.
Right.
Okay, yeah.
Hmm. So this is my equation A. Same thing I will apply over here. I will also apply KVL over here. So I get, what will be KVL over here?
V2 is equal to minus I2 RL. I2, okay, RL is 20. V2 is equal to minus 20 I2. So
V2 is equal to minus 20 I2 and your V2 is equal to 70 I1 plus 110 I2. That is equal to minus 20 I2. Okay. So you get 70 I1 is equal to
60
minus
I1.
20 I2. Right? So I get 7 I1 is equal to minus 13 I2. This is equation B. So what do I know?
then
I know
we'll get
I1 is
I2
equal to
from
minus 13 by 7 I2. So I will put this in equation A. So I will get 2 is equal to 3 into
3 I1
13 by 7 I2.
13 by 7 I2
Hmm,
plus
plus
3 I2.
3 I2. This is equal to what? Minus what?
So that is already equal to 2,
29.
right?
So this becomes equal to minus 9 upon 7 I2 plus 3 into I2.
Minus 2.5.
Okay, let me just do it. Minus 39 plus 7321 upon 7 I2. So you get it to be equal to minus 8, 18 upon 7 I2. So my I2 is equal to 2. So you get your I2 is equal to minus 2 into 7 upon 18. Okay. That is equal to minus 7 upon 9. So how much is your I2?
0.77.
So it is minus 0.777 ampere. Okay. Then we want to find the power delivered. What is my power delivered?
I square R.
Okay, this I2 square into RL. It is minus 0.777 square. RL is 20. So how much is this?
12.098.
12.098
watt.
Okay, so 12.09 watt. Okay. So now let's go to the next question. अच्छा So they're telling us to find the y parameters for this network. Okay. So how will I find the y parameters for this?
Short V2.
Mm,
And then
No, sir, it is very simple. It is a
Yes.
pi network.
What?
Sir, it is a pi network. We can simply find y plus yb. y11, y12 equal to y21 equal to minus y I12 and y22 equal to yb plus y3. Very simple.
Okay. So what I don't remember pi and star that much. What I go is I simply solve it. I suppose I have I1. I apply KCL over here. Okay. What will I1 equal to be? It is V1 upon what?
V1 into 4.
It is V1 into 4 plus V1 minus V2 into 4.
4.
So I get my I1 is actually equal to 8 into V1 minus 4 into V2. Okay. This already of
Yes.
the form I1 is equal to Y11 V1 plus Y12 V2. So I don't have to waste my time and energy. I found it already. Okay. Similarly, my I2 is equal to 8 into V2 plus 4 into V2 minus V1. So this I can write it as minus 4 V1 plus 12 V2. So I get my I1, I2 is equal to 8 minus 4 minus 4, 12, sorry, V1, V2. So I've solved the sum. So first. Okay. So within 6 lines, we have solved it.
30 seconds.
Yeah. Need for speed. Add to speed.
Sir, I have some doubts. Sir. How to know that where to apply KCL and where to apply KVL? Just by practice or?
Yeah. Practice only. And so you see over here, even if it's a normal sum, I would prefer to go for KCL because if you apply KVL, you will get 3 loops, right? But if you apply KCL, you only have 2 equations. Like if you apply
Yeah.
KVL, you have to do here, here. But if you apply, means if you do KVL, but if you do KCL, you have 1 node, 2 node, and a reference node.
A reference node.
So that's why it is simpler.
So based on that, we can decide whether it is this to apply or that.
Yeah. In most cases, this is the way I do it usually. But I think recently I went through one sum and it was better to do the opposite way. I don't remember the sum. But in most cases, this is the way to simplify it. Okay.
Yes.
So one recommendation by me is if you have a 2-port network sum, don't try to do, V2 is 0, I2 is 0, and then solve and then do. Because if you see the first sum, it took us lots and lots of time. And to my knowledge, if we had just solved the equations and then did suitable rearrangement, it would have been much simpler. That's what
The
I
first
feel.
sum which we solved.
Yeah. The first sum which we solved was this one, right? We had to find E, F, G, H. So for
Yeah,
that one, we made I2 0. And then we solved the equations. Then we made I1 is equal to 0. And then we solved the equations. So I would recommend in this case is this, if you see this network, it is also similar to the network we just solved. It is similar to network we just solved. So what I'd do is I'd find the y parameters of this network. Once I found the y parameters of the network, I'll just take the inverse. And then I'll get the z parameters.
Yeah, gotcha.
So that's another way to look at it. So my recommendation for 2-port networks, don't try to go for V20, I20, those cases. Just solve the network. It won't be that difficult because they also know.
Yes.
Yeah. So now, that was your network 1. If you see, this is your network 1. These are the parameters for your network 1. Now let us go to the next page. There's a next question. It is just an advanced version of the previous question, but it also is very simple. So what is it? Does anyone have any ideas how to solve this one? Looks very huge, very big.
Can we consider all as a single network?
Yeah, if it's only you're considering it as a single network. So it is actually
Cascading of the two networks.
it is not cascading, it is connected in parallel. So two
These are y
What?
parameters, right? So maybe they will be joined. See,
they are connected in parallel. Okay. So to simplify, I will say this is network A, this is network B. Both are the same networks. I'm just giving it a notation. Network A, network B. So let the current going in here be I1A and the current going in here be I1B. The current going in here is I2A and the current going in here is I2B. Okay. So now, what is my I1? My I1 is equal to I1A plus I1B, right? If
Yes.
I apply KCL over here,
Yes, sir. Yes.
what is my I2? My
I2A plus I2B.
I2A plus I2B. Now I know already that for my network, suppose for network 1, for network A, okay, network A, I know that I1A and I2A is equal to what? 8 minus 4 minus 4, 12. What is the voltages across it? It is V1 and V2. Right? Because the voltage over here is V1, the voltage over here is V2.
We just took it from the previous one, right?
Yeah, from the previous sum. Yes. Okay.
Yeah.
Now for network B, what can I do? For network B, I will write it as I1B, I2B is again equal to 8 minus 4 minus 4, 12, V1, V2, right? Because again the voltages are the same.
Yeah.
Okay. Now what I will do? I will add them both. I will add them both. So I will get I1A plus I1B and I2A plus I2B is equal to 8 plus 8 minus 4 minus 4 minus 4 minus 4 12 plus 12 B1 B2. Okay, so I will get what is I1A plus I1B?
I1.
So this is my I1, this is my I2. It is equal to 16 minus 8 minus 8 24 24 V1 V2. Okay. So you have solved the sum now. Done. Any queries?
But they are talking about y1 square. They have
No,
mentioned.
it is the wrong thing. It is not y1 square. Just to differentiate between for network 1 and for this combination of two networks in parallel, they have written it, but
Okay.
it y11. Okay. They're asking y11 for your two for both the networks connected in parallel. Okay. So for y parameters, both the networks are connected in parallel, you just add it. Okay.
Right.
Yeah. Any question? This is the method, right?
Yeah. For y parameters.
If it is Z in series, then we can add them.
For series, it is Z. Z parameters you can add. And for cascaded, I think you have to use ABCD parameters, but I'm not sure. You can check that.
Sorry.
Multiply. We may need to multiply.
Yes. Oops.
If the Z parameters are in series, then we can add.
Yeah. So for series connection, Z parameters of the two networks you add. For parallel, Y parameters you add. For
Yeah,
cascade,
even if the opposite is asked, we can just find this and
if they have given two
then take
networks in series,
transpose.
then you take inverse, not transpose. It's inverse.
Yeah, inverse.
Yeah. Then you do ABCD parameters. You have to check the relation, but it is like sort of multiplying. You have to check the signs. but it is actually multiplication finally. Okay. So this is for interconnection. Now we'll go to the last sum, I think. The last sum. This is the sum. Okay. So if you look at this, what are they asking?
First, we should find
Z parameters for the integrated one.
Z parameters for the overall network. Okay.
Right.
So how will you do this?
Can we ignore that middle matrix and then try to find out the Z parameters for the outer and then cascade them?
No, that is not the way.
first we
Okay,
can
so
find V1 dash and V2 dash.
Mhm.
Those inner parameters, then we'll be able to solve.
What do you mean? Inner parameters?
Yeah, first with the given Z dash
Uh,
or the Z bar, we can find that V1 dash, I1 dash, those parameters,
mhm.
and then we'll be able to solve for the overall network.
Okay, so we have V1 dash, V2 dash is equal to 20, 50, 60, 10 into I1 dash, I2 dash. Okay, so my V1 dash is 20 into I1 dash plus 50 into I2 dash, right? And my V2 dash is 60 into I1 dash plus 10 into I2 dash. Okay, so now how will I solve it?
I1 and I1 dash are equal.
Yes. So I know I1 is equal to I1 dash. So I can write my V1 dash is equal to 20 I1 plus 50 I2. Similarly, my V2 dash is 60 I1 plus 10 I2, right? Then,
And we know the relationship between V1 and V1 dash.
okay. So if I apply KVL, I have V1 minus 90 I1 minus V1 dash minus 10 I1 is equal to 0.
Right.
So I get V1 is equal to 100 I1 plus V1 dash. That is
Right.
equal to 120 I1
V1
plus 50 I2.
now we have the relation V1 in terms of I1 and I2.
Hmm.
And similarly we should get that V2 also in terms of I1 and I2.
Yeah, that's all. So now I will apply KVL. In the outer loop, I will get V2. Okay. V2 minus 30 I2 minus V2 dash minus 70 I2 is equal to 0. So V2 is equal to 30 I2 plus 70 I2 plus V2 dash. So V2 is equal to 100 I2 plus 60 I1 plus 10 I2. So V2 is equal to 60 I1 plus 110 I2. This is my B. So I will get my overall V1, V2 is equal to 120, 50, 60, 110, I1, I2. Okay.
Perfect.
So this also has been solved. So we have solved this question. We have solved all the questions for today. Got it. Now, I'd like to check one point. So, okay. So let us consider for ABCD parameters. V1 is equal to A V2 minus B I2. I1 is equal to C V2 minus B I2. Okay. Assume this is A1, B1, C1, D1. Okay. So this is my network, which is given by A1, B1, C1, D1. This is my V1. This is my I1. This is my I2. This is my V2. Okay. So I get my V1, I1 is equal to A minus B, C minus D, V2, I2. Okay. Now assume I have another network. This is given by A2, B2, C2 and D2, where you have plus minus V2 and this is your I2. Achha, let me draw a better way. Okay. So this is my A1, B1, C1. A1, B1, C1, D1. Okay. This for cascade connection. This is my V1. This is my I1. This is my V2. This is my I2. This is my V3. This is my I3. Okay.
Isn't I2 in the opposite direction? ABCD.
Here I2 is going in. I2 will be going in, right?
For ABCD parameters,
In this case, it will be minus I2.
Yeah.
Okay.
And no issue in writing like that, right?
No, there's no issue. No issue. So
Yeah.
I know my V2, and let this minus I2 be equal to some IX. I know my V2 IX is equal to A2 minus B2, C2 minus D2, V3 into I3. Okay. This is a relation. And I know, and this actually is equal to my V2 minus I2, A2 minus B2, C2 minus D2, V3 into I3. Right?
I don't think it is minus I2. In ABCD parameters, already the current is going out.
Huh.
So why it
No,
is minus
it is
I2?
IX, no? It is IX, right? Current which is entering in. No? If you see
No,
over
actually in ABCD parameter, while we are considering, already the current is going out, outwards only, right? Not in towards.
No.
So I2, direction of I2 will be in opposite direction.
See, if you see this network, this ABCD network, these
Yeah,
are the
there only I'm saying I2 will be in the opposite direction.
Huh.
If I'm not wrong.
No. You always consider for in the constraint of two-port network, you are considering it to be like this. That the current is always entering into the network.
In lecture it was maybe one.
So
No, sir. In the lecture notes, it is in the opposite direction.
no,
For
in the-
only for ABCD parameters, it is in the opposite direction.
no, if you
For
have
all other parameters, the current is delivering inside of.
if it is ABCD, this is your V1, this is your I1, this is your V2, this is your I load, right? This is how they consider.
Yeah.
So,
Yeah.
I1 is equal to A, B, C, D, V2, I load, right? This
Yes.
is the relation. Now what I have done is, I know my I load is equal to minus I2. Because my I2 is like this. My I2
We
has
are assuming it in this direction.
No. You always assume for two-port network that the currents are entering in. And that is why if you see for two-port network, for ABCD parameters, what you get is V1, I1 is equal to A, B, C, D, V2 and minus I2 you get over here.
Okay. Yes.
V2 and minus I2. And what I have done is I've taken this minus sign into the matrix. So I've got V1, I1 is actually equal to A minus B, C minus D, V2, I2. Okay.
Yes.
So this is what I have taken. And if I'm not wrong, this is also then source nodes. So this is for one network. So I've got V2 and Ix in terms of this. So V2 minus I2 is in terms of this. So I can write it as V2 and I2 is actually equal to A2 minus B2 minus C2 D2 V3 I3. I just take the minus sign, multiply it over here. So now I will use the relation. I know V1, I1 is A minus B, C minus D, V2, I2. So it is V1, I1 is equal to A1 minus B, C1 minus D1 into V2, I2. And what is my V2, I2? That is my A2 minus B2 minus C2, D2 into V3 into I3. So what is my overall ABCD parameters? It is the multiplication of these two matrices. This is my overall ABCD parameters.
Yes, sir.
Okay, so this is, I know this is a bit confusing. So you can just go through these notes again, which I will be uploading, and you can check. Perhaps I made a mistake. Perhaps there's something lacking in the question and the way notation, everything. So you can just verify it. All right.
What about that reciprocity conditions? Symmetry we have seen.
Reciprocity conditions. Okay. So what do you mean by reciprocity? So this is your network. You apply some input, okay, and you get some output, okay, some output over here. Actually, it should not be I2, will be opposite direction. Yeah. So this is your output which is coming over here. So your ratio upon V1 upon I2, that is some ratio X. Now, if you interchange your input, make this as your input, and this is your output, right? And you do V2 upon I1. That also, if you get equal to X, then you say that your network is reciprocal. So in case of Z parameters and all, it is very simple. So Z parameters, you just need your Z21 equal to Z12. Y parameters also,
y21 equal to y12.
We need y21 is equal to y1. Okay. For ABCD parameters and H parameters, I have to see. Okay, for H parameters, it should be, if I'm not wrong, let's see. I'm not able to remember what is the condition for H parameters. For ABCD parameters, it should be AD minus BC equal to 1. Okay, let me check for Y parameters. It should be half. It should be your H12 should be equal to your minus H21. This is the condition.
For symmetry condition, Z11 should be equal to Z122, right?
Yes, yes. Symmetry condition. This is Z11 is equal to Z22. Y11 is equal to Y22. In this case, H11 into H22 minus H21 into H12 is equal to 1. And here you have A is equal to D. This is the condition. Okay.
Yes.
Okay, so we'll end today's meeting. And next week you have op-amps, which is like very interesting. Because when you will be doing your projects and all, you'll be using op-amps a lot. Or you should be using op-amps a lot. If you're making hardware and all. They have good application in various signal conditioning, filters and everything. So we will be studying op-amps next. Okay.
So one more thing to the first question, what was the alternate approach you just said?
What was the ultimate?
Alternate approach. You just said something, mentioned something. It is better to solve in this method, right? Can you just?
So in this case, this is the question, right? It
Yes.
has I can't edit, I think, or what? So let me just take a screenshot. So over here, what I'll do is you have one node here, another node here, and a reference node here. So there are only two nodes. Basically, there are only two nodes where you will apply KCL, right?
Yes.
So I will find the Y parameters like this. Y parameters are very simple to find in this case. Also, there are common 4, 4, so it is very easy. It scales very well. Okay. So I will find I1, I2 is equal to Y11, Y12, Y21, Y22, V1, V2. Okay. Then what I do, this is my Y matrix. I need to find my Z matrix. My Z matrix is what? Y inverse.
Inverse.
If I just take the inverse, I will get the answer. And how is this
Yes.
inverse? It is equal to Y22, Y11, minus Y12, minus Y21. Okay. Divided by Y11, Y22, minus Y12, Y21, which is also the determinant.
Yes.
So this is very simple. This is a method which will be very easy to use. So again, I repeat, for two-port networks, don't try doing V1 is equal to 0, V2 is equal to 0, I1 0, I2 0. That makes it complicated. Just try to find a simple way to solve the circuit. Find certain relationship between I1, I2, V1, V2, and then you can manipulate it accordingly. Okay. So any other questions?
No.
Okay, so I'll end today's meeting, and then we'll have a session on 16th for week 12 OPAMs, and then we will have a session on 18th. It's a summary session. Okay.
Sure.
Okay. All the best. Huh?
Thank you.
Thank you.
Good night.